Okay, so yesterday we talked about creating equations, and then today we're actually going to talk about how to solve them. We're going to solve a system. So here are the steps in order to solve a system. Okay, so first thing you want to do when using substitution is you're going to get a replacement equation by solving one of the equations. Okay, so on this one you're going to solve one of the equations. You're going to substitute it back in, and then solve for the remaining variable, and then write the answer as an ordered pair. Okay, so all right, so what's going to happen in this first equation? What's going to happen in this first equation is it's already solved, right, for one of them. Okay, so this says x equals y plus 4, right? This one's already solved, so all we're going to do is we're going to take this equation and we're going to plug it in for this x. Okay, so we're going to say 2 times y plus 4 plus 3y equals 43. So we took this equation right here and I plugged it in for this x. Okay, distribute. So you're going to distribute. So 2 times y is going to give us 2y. 2 times 4 is going to give us 8. You're going to then combine your like terms. So 2y and 3y are going to be added together, and that's going to give us 5y. I'm going to subtract 8 from both sides. So 43 minus 8 is going to give us 35. We're going to divide by 5 on both sides. And so y is going to equal 7. Now, in our next step, we are going to take this 7 and we're going to plug it back in to the other equation. Okay, so since we use this equation to solve for y, we're going to use the other equation to solve for x. So we're going to take 7 and we're going to plug it in for y right here. So we're going to take this equation, wow, and we're going to plug in 7 in for y. That is a 4. It looks like a special 4. We're coming from my 4. Fine, special. There we go. Okay, so when I add these together, I'm going to get x equals 11, right? Now my final step says to write this as an ordered pair. So we're going to say 11, 7 as our final answer. So if you want to make sure that you're right, you're going to take 11 and 7 and plug them into the second equation. So 2 times 11 plus 3 times 7. So 2 times 11 is 22. And 3 times 7 is 21. If you add those together, you'll get 43, which is what is on the other side. No, you don't have to do it. That's just one way to check. Yeah. Because, like, you shouldn't, theoretically, you should not get these questions wrong. Like, because you can plug it back into 2 separate equations. Like, I said theoretical.
So it feels like y equals x plus 4.
Yeah. Right. Okay, so let's look at the next equation. Okay, so on this next one, it's not set up so neatly. So we're actually going to have to solve for one of these. Which one do y'all want to solve for? E? Okay. And which equation do you want to start with?
3.
The bottom one, right? Okay, because that's going to probably be the easiest one to solve for, right? Okay, so if I want to get E by itself in the second equation, I'm going to subtract 2f from both sides. And that's going to give me E equals negative 2f plus 4. Okay, so now we've got this set up the exact same way as the last problem. Okay, so we're going to take this and we're going to plug it in for E and we're going to solve. Go ahead and take a moment and try that on your own. Take this equation, plug it in for E, and then solve for F. So here it is again. Take this equation that we just solved for, plug it in for E, and then solve for F. So I'm going to take this, and I'm going to plug it in for E. So that's going to give me 3 times negative 2f plus 4 plus 4f equals 11. So all I've done is I've taken what I got right here, and I plugged that junk in. So this I'm going to plug in for here. Okay? So then I'm going to multiply. So 3 times negative 2f is going to give us negative 6f. 3 times 4 is going to give us 12 plus 4f. I'm going to combine my like terms. So negative 6f plus 4f gives us negative 2f. And then I'm going to subtract 12 from both sides. And so that's going to give me negative 2f equals negative 1. I'm going to divide by negative 2. And so f is going to be 1/2 or 0.5 for those of you who want to use it as decimal. Okay? Questions on that so far? I'm going to take 1/2 and I'm going to plug it into the second equation. So that's going to give me e equals, e plus 2 times 1/2 plus 4, or equals 4. Okay, so this equation is what we plugged into. So 2 times 1/2 gives us 1. And then if I'm solving for e, I'm going to subtract 1 from both sides. And so e is going to equal 3. Is that, since this says e and f and not x and y, well, how do you write it as an ordered pair? Okay, you always write it in alphabetical order. Okay, so x comes before y. That's why we write it x, y. No, just me. Okay, so this will be 3, 1/2 as our final answer because e comes before f. Okay, and that works 99.9% of the time. Because sometimes they like try something stupid and they're like, actually switch them the other way. But you got to just read the problem. I think the SAT is the only place that I've seen that. I'm just being honest. Okay, go ahead and flip that page. Is by elimination. Okay, so make sure your columns contain the same type of info. So that means like make sure your x's and y's are matched up. Make opposites in one variable columns by multiplying, which we're going to see that in just a second. Add each column to eliminate one of the variables, and then solve for the remaining variable. Substitute the value into the original problem, and I'm just reading this for myself because you're not paying attention at this point. But maybe. Okay. All right, so on this first question, what you're going to see is this 3x and this negative 3x, right? So we're going to add these two equations together. Okay, so 3x plus negative 3x, that's going to cancel out, right? So 4y plus y is going to give me 5y. 23 plus 2 is going to give me 25. Okay, so when we solve, we're going to divide by 5 on both sides. And so y is going to equal 5, right? Okay, so now we're going to take 5 and we're going to plug it back into the other equation. And really on this one, you get to kind of pick. It doesn't matter. It should be the same on both unless you've done something wrong. Okay, so if you take 5 and you plug it back in, I'm going to plug it into the second equation. Okay, so if I plug it into this second equation, where that y is, I'm going to write 5. So I'm going to subtract 5 from both sides. Negative 3x equals negative 3. I'm going to divide by negative 3 on both sides. And x is going to equal 1. Okay? So as our final answer, we're going to write this as 1, 5, because we want to write that as an ordered pair. Or you saw me do this problem and you were like, dang, that's really easy, right? Like elimination is easier than substitution. Now it doesn't always work, or it's not as clean as what this was. Let's look at number 2. Okay, so like as y'all can see, like I can't just add these two together and something cancel out. Okay, so now I've got to kind of finesse this a little bit. So do we want to get rid of A or B? You tell me. Get rid of B. Okay, so you see how this is a 6 right here and this is a 2 right here. Well, what multiple do these both share? And let's try that again. That's a factor. 2 is a factor. 3 is not a factor. A multiple is like, if I say 2, 4, 6, a multiple of 6 would be 6, 12, 18. 6. So what do they both share? 6. Okay, so this one's already 6, right? So I don't have to do anything to that guy. But down here, what am I going to multiply in order to turn that into a 6? A negative 3. And the reason why I'm multiplying by negative 3 is because it's going to cancel it out, right? Okay, so I'm going to take everything in this second equation and I'm going to multiply it by that negative 3. You can't just do it to one part of it. You have to do it to the whole equation. So I'm going to rewrite this equation over here. So a plus 6b equals 18. All right, let's see if I make the same mistake in this class. Negative 3 times 3a is going to give me negative 9a. Negative 3 times 2b is going to give me negative 6b. Negative 3 times 2 is going to give me negative 6.
So you always want to, so you see where it's negative 3?
Yeah.
You always want to do the opposite of what's inside.
You want to do the opposite of whatever the sign is, like up here. So like if this is a plus up here, then this needs to be a minus down here when you multiply. Yeah. So now when I add these together, you see how these cancel out?
Yeah.
Okay, so a plus negative 9a is going to give me negative 8a. 18 plus negative 6 is going to give me 12. I don't know. I'm just struggling, y'all. Listen, earlier today, 18 times 3 was like some other number. It was not 54. Okay, divided by negative 8 on both sides. I'm going to blame it on the fact that I had class last night. 12 divided by negative 8. 12 divided by negative 8. Yeah, don't come for me. 12 divided by negative 1.5. Okay, so a is negative 1.5. All right, so what you're going to do with that is you're going to actually plug it into this other equation over here. Okay, so we're going to take this first equation that you had up here, the original first equation, okay, and you're going to take a plus 6b equals 18, and you're going to plug in that negative 1.5 in here. So we're going to add 1.5 on both sides. Okay, so 6b equals 19.5. Okay, so then we're going to divide by 6 on both sides, and b is going to equal 3.25. So as our final answer, remember, we're going to put this in alphabetical order. Okay, and that's going to give us negative 1.5, comma 3.25. Gucci. So there's elimination, there's substitution, and now there's graphing. So on this problem, it says a game swap membership costs $20 and includes one game per month for $5. Non-members can get one game per month for $7. So we're going to look at independent variables and dependent variables. So the independent variable is the one that can stand alone, is not affected by the other things. Okay, so in both of these, we would write an equation, right? Okay, so let's go ahead and write that equation. So for the membership one, that's going to be $20, so that's going to be my initial fee, right? And then it's going to be $5 per month. For my non-members, they don't have to pay an initial fee, but it's going to be $7 per month, right? So these are my two equations. Now, my independent variable is my x term. What does this x term represent? The number of months. Yay. And my dependent variable represents what? That's my y value. Total amount spent, whatever you want to call that. I'm going to call it a total amount. Okay? You graph this, what's going to happen is on the y-axis, you're going to put the dependent variable, which is the total amount. On the x-axis, you're going to put the number of months. Okay? I'm going to pause. I labeled the sides. That's going to be months on the bottom and total amount on the side. I went up by 5s because it's just going to be easier and neater to see. So we're going to graph this first equation. The first equation, you're going to start at 20, and then it goes up by 5 each time, right? Yeah. So it's going to look like this. And I would probably do it for the entire graph because, again, you're going to see something happen a little bit in a little bit. Oh, look at that straight line. Boom. Okay. All right, let me live my life. Okay, so then for the second equation, which I would suggest doing in a different color, when we plug in 0 into here, it's going to be 0. And then when we plug in 1, it's going to be 7. And then when you plug in 2, it's going to be 14. And when you plug in 3, it's going to be 21. And what's happening is this is going to grow up by 7 over 1. And they're going to cross at 70. We're going to cross out 70, or 2 times 12, sorry. Okay, so these are your answers for the rest of that. So again, after 10 months, because it's going to be cheaper then, less than 10 months because non-member is cheaper.